Hey guys, this is Caroline Hurry. This is Thomas, Carson, and Kate, and we have decided to study the Caprigliola bridge collapse. So, the bridge connected Caprigliola and Albiano in Italy. It crosses over the Magra River. It was designed by Attilio Muggia, and it began construction in May of 1906 and ended in 1908. And the bridge collapsed in 2020. So this photo was taken before the bridge collapsed, and this is a simulation of the collapse. These next photos were taken after the collapse. And finally, this is the new reconstructed bridge.
The bridge was damaged from mines during World War II. It was then reconstructed from 1945 to 1949. The reconstruction engineers were Arrigo Carre and Gregorio Gianelli. The upper parts of the bridge were reconstructed, but the lower parts of the bridge were retained from the original construction. The bridge is constructed from reinforced concrete, and it consists of 5 spans that are supported by 5 arches, which rest on 4 pylons. The total length is 260 meters, or 850 feet, and the total width is 7.2 meters, or 24 feet, and the total height is 10 meters, or 33 feet. The excavation method is dug through waterlogged ground using a pressurized caisson to consolidate pillar foundations.
The details of the failure of the bridge include: first, the thickened slab made cracks in the bottom slab not visible during inspection, so it was not noticed. Second, piers were separated from the foundation. Third, there was a deck failure that showed misalignment between the original slab and the additional slab that was added in the 1990s. Next, there's the initial local failure led to a cascading collapse that looked like a domino effect. And lastly, the pier rotated and tipped over, causing the local failure and the bridge to collapse.
So this is a diagram showing the predicted failure points for the bridge. They predicted it be between Pier 3 and Pier 4, or between Pier 4 and the connection A2. You can see under Pier 4 the sediment movement that is likely caused most of the failure. So these images, as you can see in image A, represent the misalignment of the piers from the foundation after the collapse. And then along with image B, it shows the outlines of the new and old slab, with the original slab being highlighted in green and the added slab in the 1940s highlighted in red. And you can see why they missed the cracking in the original slab, because it was covered by the new, much bigger slab. And this image shows different pictures of the aftermath after the collapse. As you can see where each pier was ripped apart and disconnected from the main bridge. So why it failed: the reinforcing was not sufficient. The 3-hinge arc that was redesigned in the 1940s caused horizontal and vertical movement, which led to cracking. The inspection was not thorough, so when they came and inspected the cracks, they passed up on fixing that. They misidentified those cracks as insufficient. And then the sediment rotation at the piers also created some stress on the structure. And then finally, overloading. The infrastructure was not updated to meet modern standards, and the concrete slab was thickened in the 1990s without updating any reinforcement.
The lessons our group learned: first was that thorough inspection is very crucial. Second, when updating a structural system, you need to make sure to consider the implications on the existing system. And lastly, include extra reinforcing when a load is added to the system.